Using this Cayley's table, let's try to determine whether the operation star is associative. We're already given with this star and we are sure that it's a binary operation because by looking at our Cayley's table, the elements of our set, whatever set would that be, contains elements A, B, C, D, and E. And when operating to the elements themselves, all the resulting elements here are still elements or the same elements A, B, C, D, and E. The thing now is we're going to determine whether this is associative. Now, there is no clear indication or process for us to determine whether a certain Cayley's table is associative just for the present concepts that we have. Of course, we're going to really apply our analysis here and pick 3 different elements and see if the results would be the same. But what is the assurance given to us is that even just one counter example, without looking the other examples that will fail associativity, only one, it's already enough for us to say that it's not associative. But if as soon as we are examining set of 3 different elements of the given set and still associative, we're going to proceed further in determining whether it's still associative or not with the use of the other elements. Let's try to use here A star B star C. Is it the same as A star the group of star B star C? This is the general form of associativity. So if using this Cayley's table, we can determine the result if the same results here. So A star B, so we have your column here A, because this would be our first elements, the row, and the column would be our second element, A star B. The result is B. So we can have it here. This is actually B star C. Okay, let's start with this first. And we will have B star C. Okay, so we're going to use now this B as the result of A star B. So B would be our row, star C. That's actually A. That's the result of B star C. So you will have here A. Let's check if it's the same when we are going to apply the second groups here rather. So let's start with this. We have A star, whatever will be the result of B star C. So we have it here, B, we have the row, and C. It's actually A. So B star C is A. So it's A star A. And if we're going to look closer, A here, row, and column, the result here is A. So A star A is just the same as A itself. Okay. Now, is it safe for us to say that our star is associative? Because we can see here that A is equal to A, and this, what do you call this one, satisfy the condition. As mentioned earlier, it's not enough for us to say that it's associative just by one example. Let's move further. And what if we are going to use here this A star B? Let's go to D. Is it the same as A star B star D? Okay, so let's start with A star B. We already have the result earlier here. So let's have A star B is actually B star D. Okay, B star D will have this row here, B star D. Okay, the result is E using the Cayley's table. So B star D is equal to E. Sorry, let's not put it there. Okay, we'll have it here at the bottom. B star D is equal to E. Okay, so is this the same? If we're going to manipulate the other side, we'll have here the grouping symbol of B star D, just like earlier, B star D is equal to E. So it's equal to E. So A star E here, will it result to E? Let's check. A star E. The intersection is D. So A star E is equal to D. what can you see here is that they are not the same. E is not equal to D. Even if the first example shows associativity, the second example doesn't show associativity. And with this, we can say that star is not associative. Just by one counter example, it's enough for us to say that it's not associative, even if we have examples or sets of elements that will make associativity true. But if we only have even just one, that is enough for us to say that it's not associative. So this is how we determine associativity of certain Cayley's table. Thank you very much for watching.